Hello, this is our second lecture for solutions or Unit 10. All right, so solutions, Unit 10. Okay, hopefully you watched the lecture video from last week for solute, solvent, words like soluble and insoluble, being able to change how soluble something is. So we're going to pick up with an understanding that you guys have already seen and heard those terms. So another term involving solutions is the word aqueous or AQ, and this refers to when a material is dissolved in water. So we spoke last lecture about how water is the universal solvent. It's typically what is being used when we're making solutions. So the purpose of this lecture is we're going to explore different types of solutions that could occur. So one of them is called an electrolyte. So, an electrolyte, dissociation of ionic compounds or salts into ions to conduct electricity when dissolved in water. So, anytime you have something that is ionic or we have a metal bonded to a non-metal, it's classified as a salt. And we talked about that when we went over bonding and then probably again in Unit 5, chemical nomenclature. So ionic compounds, when you dissolve them, they will conduct electricity in water. And you actually saw that as a demo in class where I had a beaker and then I was able to put a light bulb into the beaker and I made the light bulb glow. The light bulb, we looked at how a solution of salt water can conduct electricity, but the covalent compounds did not. So our new term for anything that's going to conduct electricity or make a light bulb glow is considered an electrolyte. So, what's happening chemistry-wise to make this light bulb glow is the dissolving takes place at the surface of the solute. So these molecules here are water molecules. Anyone that you see, the H2O, okay? The water molecules are actually ripping apart the ionic compound. So here's sodium, here's chlorine. So just like with your car battery, when you have positive charges and negative charges floating around in solution, you're going to be able to conduct electricity or complete a circuit. All right, so on this lecture slide, all you're seeing is this light bulb glowing, giving us the proof that we need that this lecture slide, like I said, is just giving you a visualization of how the light bulb can glow when it's in a solution of table salt. So just like I mentioned, the positive ions for sodium are being attracted to that negative anode. The chlorine ions are being attracted to the positive side. And so therefore our circuit is complete and you're able to conduct electricity. So you have probably often heard the word electrolyte when it comes to Gatorade. So all this is telling us is that Gatorade has salt in it. If you think about when you go for a big workout, maybe you've been running or you've been in the gym, you've been doing something, you sweat a lot, right? And so when you sweat, that sweat is salty. So Gatorade helps replenish your salt, but it also has yummy sugar, in it, to make it taste good. So Gatorade has electrolytes in it, and I think they do a great job from a marketing standpoint to make it seem like these electrolytes make you a better athlete, but they are good for recovery in terms of helping you recover your salt. There are other ways to recover your salt that's probably not going to give you as high a dose of sugar as well. So, if you've ever had to go to a hospital and get fluids, maybe you've been really, really sick with like a stomach virus, or maybe not you, but a family member or a friend and they get hooked up to an IV, you're receiving an electrolyte solution. So you're getting um, salt back in this fluid that you've been losing while you've been sick. And that typically makes you feel better and helps you get rehydrated. If you've ever had Pedialyte, I might be spelling this wrong, Pedialyte will also do this for you as well. So, anything that does not conduct electricity in water is going to be a non-electrolyte. So these are typically going to be our covalent compounds like sugar. Okay? So, non-electrolytes do not conduct electricity, so that we're going to have no glowing bulb, okay, when it's dissolved in water. So anything that's covalent is going to be a non-electrolyte. So here's a good summary. Non-electrolytes or covalent compounds do not make our light bulb glow. There are some things that are called weak electrolytes, so they're going to have a dim light bulb. But strong electrolytes like ionic compounds like table salt, NaCl, is going to have a bright light. So the more ionic substances you have, the more ionic substances you have in your solution, the brighter the light's going to happen. So the more ionic or salt type of solutes. So remember, all of these are solutes, and our solvent is water. Okay. Some forms of Gatorade are going to give you a dim light bulb. We've done a demo before where I think it was like the purple Gatorade, that frost kind, that makes the light bulb be kind of dim. So non-electrolytes or covalent compounds do not conduct electricity. Electrolytes or ionic compounds do conduct electricity. So the next type of solution that I want you guys to learn about, sorry, my slides keep going backward, are having to deal with concentration. So concentrated versus dilute. Lots of material dissolved versus very little dissolved. So to demonstrate this purpose before these words, before I get going on these PowerPoint slides, I want you to think about how if you were to buy sweet tea from McDonald's or Chick-fil-A or Bojangles or whatever in the morning at 8 a.m., it's going to taste delicious. It's going to be full of those ice cubes and just nice and refreshing. But if you happen to carry around that same cup all day long at school, and then you sit down to drink it at 2:30 in 7th period, it's not going to be good. Equals not yummy, right? Because by the time 2:30 has rolled around, all of those ice cubes have melted. So sweet tea at 8 a.m. is going to be concentrated, right? You've got just the right amount of sugar, just the right amount of tea. But as you go throughout the day and those ice cubes melt, and by 2:30, your tea is now going to be dilute. Okay, so we've added water to it. So this would be like our 8 a.m. sweet tea, and then this is going to be like our 2:30 p.m. sweet tea. Okay, so concentrated versus dilute. How much material is dissolved versus very little being dissolved? So dilute means that there is more solvent present. What is the universal solvent? Water. So if you look here at beaker A, this is a very dilute beaker. We have lots of water, and then these circles here, these are our solute. So in terms of solute to solvent, things that are dilute are going to have more solvent than they are going to have solute. Okay, so dilute. equals more solvent or more water than you are going to have your solute. So if you were to have a concentrated solution, that means that you have lots of solute dissolved in the water. So if you look here at beaker B, all of these circles are showing us our solute. So in order for something to be concentrated, you're going to have more solute than you do solvent or water. Okay, so dilute, we have lots of water. If something's concentrated, then we have lots of solute present. So, a saturated solution contains the maximum amount of solute. You're not going to be able to dissolve any more. If you have an unsaturated solution, then that means that you have less than the maximum. So, that means that you're going to still able to dissolve solute. Okay? If something is saturated, you are not able to dissolve more solute. Okay? So, saturated, you have as much solute dissolved as you can. You can't make any more disappear as you're stirring. If something's unsaturated, then you can keep stirring up that solute and making it disappear. Now, a supersaturated solution is when you can actually make your solvent hold more solute, but you're going to add heat to it. Okay, so let me talk about this for a second. Rock candy is a very, very delicious super saturated solution. You can actually make this at home. Some of my students once before, we tried to use like Kool-Aid and we tried to use different flavorings to make our rock candy taste good, but you can actually look up an at-home recipe to make rock candy. So what's happening is you'll have a container of water, okay, and you're going to add sugar in. And then eventually, you're not going to be able to add more sugar in, okay? Once you reach that point, to make it super saturated, we're going to have to start heating it. So here's my heat source. As you start to heat your water, and you continue to stir, you can kind of make your solvent hold more solute. And so when that happens, and you let it all cool down and you let this rock candy sit for a couple of days, you actually form crystals. So when something is super saturated, we heat it up, we dissolve more, and then eventually crystals are going to form. Okay, which is, like I said, super delicious and yummy. So, unsaturated solution, you're able to keep dissolving more and more solute. Okay, a saturated solution is like Goldilocks and the Three Bears, right? So, unsaturated, yeah, sure. Keep adding in more sugar, keep adding in more solute. Saturated solutions are where no more solute is going to start dissolving. You'll be able to recognize it because you're going to have some solute left over. Okay? So, in order to make something super saturated, you just keep adding more and more solute in. So, more solute. But the only way we can make that solvent hold more solute is to add heat. So you have this on your stovetop, or if we were in a lab, we would have it on a hot plate. And obviously we'd be stirring, just like we talked about in lecture number 1. So when these crystals form, it's our evidence that a supersaturated solution has formed. So again, rock candy is our example for a supersaturated solution. So we talked about electrolytes. We've talked about concentration, and then within the ranking of a concentrated solution, you can have something being unsaturated, saturated, and supersaturated. Okay, thank you for watching. If you need to rewatch the video and go back and take more notes, please do. Thank you.